Hi students, coming to next topic, that is types of microcontroller, that is 8051 microcontroller. So far we discussed about microprocessor introduction and evaluation and components of microprocessor, introduction to microcontroller. Now today we will see types of microcontroller and features of microcontroller. Okay, so today's content is types of microcontroller, features of 8051 microcontroller. Okay, so before that, what do you mean by a microcontroller? Okay, so microcontroller is a compact integrated circuit designed to perform specific task. Okay, to perform specific task within an embedded system. So it includes a processor and memory and peripheral devices. Okay, so those are integrated on a single chip, that is called as a microcontroller. Okay, so the applications of microcontrollers are widely used in various different devices such as LED, light sensing and controlling device like LED, and temperature sensing and controlling device like microwave oven and chimneys. Next, fire detection and safety device like fire alarm and measuring devices like voltmeter. Okay, so these are the some applications of microcontrollers. Okay, so now let us see the types of microcontrollers. So here are some common types of microcontroller. So based on bit configuration, these microcontrollers are divided into 4-bit microcontroller, 8-bit microcontroller, 16-bit microcontroller, and 32-bit microcontroller. Okay, so this 4-bit microcontroller, it is a very simple microcontroller, typically used in small and low-cost devices. 8-bit microcontroller, it is used for simpler applications like appliances and basic control systems. And 16-bit microcontrollers are used for more complex applications with moderate performance. And 32-bit microcontrollers are used for high performance microcontrollers, often used in more advanced applications like smartphones, robotics, and IoT devices. Next one, memory or device. So there are two types, embedded memory and external memory. Embedded memory is nothing but microcontrollers with embedded memory have their program memory built into the chip. Okay, so internal memory, like, right? So commonly used in simpler devices. External memory. So these microcontrollers interface with external memory and allowing for more complex applications that requires more storage. Okay, so next, based on instruction set, there are two types, that is RISC, reduced instruction set computer. So this uses the simplified set of instruction for fast performance, commonly found in ARM architecture. Next, CISC. So these are more complex set of instructions, allowing for more direct and varied operation. So typically found in legacy systems. Next, based on architecture, memory architecture, those are divided into Harvard and Princeton architecture. Princeton architecture is also called as a Van Neumann architecture. Okay. Next family, 8051. The microcontrollers are divided into various family based on their manufacture or design architecture. So 8051, widely used microcontroller architecture, originally designed by the Intel. Okay, the subtypes includes Intel, Philips, Atmel, Simon, Dallas. Okay, so and these are other families, that is Motorola. So a family of microcontroller developed by Motorola, which has been popular in automotive and industry application. Next, pick microcontroller. Popular family from microchip, used for general purpose applications. And Hitachi, Texas, ARM, so other microcontroller represent different manufacturers or architecture types, with ARM being particularly important for high performance application like mobile and embedded systems. Okay. So now we will see individually. So microcontroller classification on the basis of bit configuration. Okay. So based on bit configuration, the microcontroller is further divided into four categories. That is 4-bit microcontroller, 8-bit microcontroller, 16-bit microcontroller, 32-bit microcontroller. Okay. So the 4-bit microcontroller is used to execute arithmetic and logical operations like addition, subtraction, multiplication, and division, etc. Okay. So, for example, Texas Instruments TMS 1000 are the 4-bit microcontroller. Okay. So, in this 4-bit microcontroller, so only 4 bits to perform any operation like addition, subtraction, multiplication, and division. Okay. Next one, 8-bit microcontroller. So this type of microcontroller is used to execute arithmetic and logical operations like addition, subtraction, multiplication, okay, division, etc. on 8-bit, okay, 8-bit data only. Okay. So the examples for this is 8051 microcontroller, PIC 16, and AVR at Mega. Okay, these are the some examples. And the 8-bit microcontroller are low processing power and typically used in simple applications like appliances, toys, or simple control systems. Okay. So next one, 16-bit microcontroller. Okay. So this type of microcontroller is used to perform same as well as arithmetic and logical operations, where high accuracy and performance is required in the 16-bit microcontroller. So for example, MSP 430 and PIC 24 and Intel 8096 are the examples for 16-bit microcontroller. And these are used in more complex tasks like industry control, medical devices, and some automotive systems. Okay. Next one, 32-bit microcontroller. Okay. So these are used to perform arithmetic and logical operations on 32-bit. Okay. So the examples for 32-bit microcontrollers are ARM Cortex processor ESP32. Okay. These are the some examples. And these are high, it gives high performance and capable of running more complex algorithms used in applications like IoT, smartphones, advanced robotics, and real-time processing systems. Okay. So these are the four based on bit configuration. Okay. So next we will see microcontroller classification on the basis of memory. Okay. So the based on memory further divided into two categories. Okay. First one, embedded memory, and the second one, external memory. Okay. So first we will see external memory microcontroller. Okay. So these microcontrollers requires external memory chip to store the program code or data. Okay. So they either lack internal memory or need additional memory to handle the large programs or data set. Okay. So that's why we are providing external memory. Okay, so it can support large memory. The advantage of external memory is it can support large memory capacity than embedded memory microcontroller, and suitable for complex applications. Okay, these are suitable for complex applications, and requires more storage. Okay, so but at the same time these external memory microcontrollers have drawbacks. Okay, so these are slower due to memory being externally adding external latency. Okay, so and if we are adding external memory means cost, increased system cost, so due to additional memory components. Okay, so examples for this external memory microcontroller is 8051 microcontroller. So some ARM based microcontroller supports external memory interface. Okay, next one, embedded memory microcontroller. Okay, so this type of microcontroller is designed in such a way that microcontroller has all programs and data memory, counters, timer, interrupters, input output, that is peripheral devices, are embedded on the chip. Okay, so these microcontroller have on chip memory, meaning both program memory is nothing but for code storage, and data memory. So both are integrated into the microcontroller itself. Okay, so by embedded memory, so the faster access to memory, as everything is located internally within the same chip, right? So we can access faster memory, right? And reduced overall system cost, since external memory is not required. Okay, so cost also less. And next drawback of this embedded memory is, if for any application memory is required, means we need to connect external, that is limited memory size. The drawback is limited memory size. So examples for this embedded memory microcontroller is 8051 microcontroller and AVR microcontroller. Next one, PIC microcontroller. Okay, so this is about the microcontroller classification based on memory. Okay, so how many two categorized, two further divided into two categories. One is external, embedded. Embedded means within the chip. External means we need to connect externally. Okay, next one, microcontroller classification based on the instruction set. Okay, so based on the instruction set, it is further divided into two types: CISC, complex instruction set computer, and the second one is RISC, reduced instruction set computer. Okay, so the microcontroller is based on the instruction set, which defines how the CPU process the instruction. Okay, so those are categorized into two, primarily categorized RISC processor and CISC processor. Okay, so these two categories influences how efficiently the microcontroller executes the task, and the complexity of its design and its performance. Okay, so first we will see the CISC characteristics. Okay, so we are having these are the characteristics of the RISC. Okay, so first one, simpler instruction, hence simple instruction decoding. Okay, so first characteristic is the simpler instruction. Okay, so RISC uses a small simplified set of instructions. Okay, so this simplicity allows for faster and easier instruction decoding and reducing the complexity of the control unit. Okay, so this is the first one, that is simpler instruction and simple instruction decoding. Okay, so next one, instruction comes under size of the one word. Okay, so each instruction in RISC, okay, each instruction in the RISC is typically of a fixed side. Okay, so this uniformity makes fetching and decoding instruction easier and more predictable for the processor, that is CPU. Okay, next one, single clock cycle execution. Okay, next one, single clock cycle execution. Okay, so most of the RISC instructions are designed to be executed within the single clock cycle. So this enables faster instruction throughput and maximizes the efficiency of the processor. Okay, next one, more general purpose register. So the RISC architecture have a larger number of general purpose registers. Okay, so having more registers reduces the need for memory access. So which is slower compared to register access. So thereby speeding up operation. Okay, next one, simple addressing mode. Okay, so RISC processors are fewer and simpler addressing modes for accessing the memory. So this reduces the complexity of the instruction execution and allows more efficient processing. Okay, and the next one, fewer data types. RISC architecture supports fewer data types, which simplifies the design of both the hardware and the instruction set, so resulting the faster and more efficient execution. And the last one, a pipeline can be achieved. Okay, so RISC designs are optimized for pipelining. So a technique, pipelining is nothing but a technique that allows multiple instruction to be processed at different stages. Okay, so fetching is one stage, decoding and executing. Okay, so simultaneously. So this boosts the performance by allowing instructions to overlap in execution. Okay, so these are the characteristics of RISC. Okay, so these enables RISC processor to achieve high performance and efficiency, especially in applications requiring low power consumption and fast processing, such as embedded systems and mobile devices. Okay, so next we will see the characteristics of CISC processor. Okay, that is complex instruction set computer. So first one, complex instruction, so complex decoding. Okay, CISC architecture have a large set of instructions and including some that this can be perform multiple operations in one instruction. So this complexity increases the difficulty of decoding instructions and requires more sophisticated hardware. So next one, instructions are larger than one word size. So CISC instructions can vary in size and often larger than a single word. So the variable length instruction set allows for more complex operations but makes the instructions fetching, decoding and more complicated, that is compared to RISC processor. Okay, next, instruction may take more than a single clock cycle to execute. Okay, so many CISC instructions performs multiple tasks such as fetching, decoding and executing and memory access. So all in a single instruction. So as a result, many instructions can take several clock cycles to execute fully. Okay. So next one, less number of general purpose registers. Okay. So CISC processor typically have fewer general purpose registers than RISC architecture, because CISC instructions often perform operations directly on memory, reducing the need for multiple registers. Okay, so that is the thing. And the next one, complex addressing mode. So CISC supports a wide variety of complex addressing mode. So example, direct, indirect, indexed and mode. So this allows for greater flexibility in accessing memory and data, but it also increases the complexity of instruction execution and hardware. Okay, next, more data types. Okay, so CISC architecture typically supports a wide range of data types, including integers, floating point numbers, characters, and complex structures like arrays. Okay, so this diversity increases the instruction set's functionality, but also adds the processor's complexity. Okay, so these are the characteristics of CISC processor. Now we will see the comparison of RISC and CISC processor. Okay, so first one, instruction set, already you know. So RISC is the simple and few instructions it may have, right? Next, CISC, it has complex instructions, and in the instruction length is fixed in RISC, and whereas variable in CISC. So execution, it needs a single clock cycle, most instructions. Okay, in CISC processor, multi cycle for many instructions, and coming to registers, more number of registers in RISC, and in CISC fewer registers. Okay, and code size larger due to simpler instructions, and smaller due to complex instruction. Okay, in CISC the instruction set is complex, means the program code size is smaller due to we are writing the complex instructions, right? Power consumption in RISC processor is low compared to CISC processor. Memory access, fewer memory access, and frequent memory access is available in CISC. Right? Performance, faster execution, and easier to pipeline, and RISC slower due to complex instruction. So application areas are in RISC IoT, mobile devices, real-time systems, and CISC legacy systems and industry control. Okay, so next, classification of microcontroller according to the memory architecture. Okay, so there are these are classified into two types, two categories, that is Harvard memory architecture and Princeton memory architecture, or Van Neumann memory architecture. Okay, so in Harvard architecture, the microcontroller has a separate memory. Okay, separate memory for program and data. Okay, program is nothing but code, program code and data. So this allows simultaneous access to both instruction and data memory. So then increasing the performance and throughput. Okay, so whereas in Van Neumann architecture, um, the microcontroller uses a single memory space. Okay, single memory space for both, that is program instruction and data. This means instruction and data are stored in the same memory. Okay, so instruction and data are stored in the same memory. So accessed via the same bus. Okay, so common bus it will use to access the program and data memory. Okay, so we will see the differences between the Van Neumann and Harvard architecture. Okay, so the uh, Harvard architecture is nothing but it uses separate memory, that is program memory and code memory, separate buses for program and data memory. So this microcontroller has dedicated buses for accessing the instruction, that is program memory and data. Okay, enabling parallel fetching of instructions and reading or writing of data, that is right in Harvard architecture. Okay, and whereas coming to Van Neumann architecture, the data and program memory stored in the same memory. Okay, a single bus is used for both fetching the instruction and reading writing the data, so which can create a bottleneck since instructions and data cannot be accessed at the same time. Okay, and next parameter is, that is buses. So common bus for address, that is and code. Okay, address and data or code in Van Neumann architecture. Okay, so whereas in Harvard architecture separate buses for data and code. Okay, so program execution, code is executed serially and takes more cycle in Van Neumann architecture, whereas in Harvard architecture code is executed in parallel with data, so it takes less clock cycle. Okay, so that's why Harvard architecture faster execution, since the instructions and data can be accessed simultaneously. Okay, so this architecture often leads to faster program execution, whereas coming to this Van Neumann architecture, right here the slower execution, because the instruction and data are fetched from the same memory using the same bus, and it may take longer to execute the instruction. Okay, next design complexity. So the Van Neumann architecture is simpler design. So this architecture is a simpler to implement in hardware compared to Harvard architecture. Okay, so whereas this Harvard architecture is more complex. Okay, and sorry, and usage of this Van Neumann architecture, risk-based microcontrollers it is used, and DSPs, digital signal processor, and Harvard architectures are used in CISC-based microcontrollers and simpler systems. Okay, next one. 8051 microcontroller features. Okay, uh, what are the features? First point and most important point is 8-bit. It is a 8-bit processor. Okay, so 8051 microcontroller originally developed by the Intel in 1981. Okay, so one of the most widely used microcontrollers in embedded systems due to its simplicity, flexibility, and affordability. Okay, so these are the some features. First and foremost important feature is it is a 8-bit processor. Okay, so the microcontroller is a 8051 microcontroller is a 8-bit processor. It can process 8 bits of data at a time. It can process 8 bits of data at a time. So the data bus accumulator, most of the registers are 8-bit wide. Okay, so next point is memory. Okay, so in 8051 the on-chip RAM, the standard 8051 has a 4 kilobytes of read-only memory for storing the program code. Okay, it is having 4 kilobytes of program memory for storing the program code, right? So this is sufficient for simple embedded application. On chip RAM is 128 bytes of RAM for data storage and stack usage. Okay, and if needed, external memory support is available. It supports up to 64 kilobytes of external read-only memory and 64 kilobytes of external random access memory, which can be interfaced for more complex applications. Okay, and it has a 16-bit program counter and a 16-bit data pointer. So program counter is nothing but it is used to hold the address of the next instruction to be executed. Okay, so program counter. So these two registers are of 16-bit wide. Next it has a 8-bit program status word. Okay, it has a 8-bit program status word and it has a 8-bit stack pointer. Okay, and this memory already discussed. Next feature is the 8051 microcontroller is having 8-bit IO ports, 4 8-bit IO ports. Okay, so 8051 is having 4 parallel IO ports, each of 8 bits, providing 32-bit IO pins. Okay, so these ports are bidirectional and can be used for interfacing with external devices such as LED switches, motors, or sensors. Okay, next one, 8051 is microcontroller is having two 16-bit timers or counters. Okay, so that can be used for timing operation, generating delays, or counting the events. Okay, the timers can operate in different modes. Okay, next, control registers. Okay, so these are TCON is the timer control register. TMOD register, mode selection, serial communication is CON, PCON, and interrupt priority register IP and interrupt enable I. Okay, these are the control registers. Okay, next one, the 8051 is having two external and three internal interrupt sources. Okay, two external interrupts are INT0 and INT1, and two timer interrupts are timer 0 and timer 1. One serial communication interrupt, that is UART. Okay, so these interrupts have a priority structure and can be enabled or disabled through software. Okay, next, it has a 8-bit bus and 16-bit address bus. 8-bit is for data bus, 16-bit address bus. So the clock frequency is 1 megahertz to 40 megahertz, and the operates with a single power supply, that is plus 5 volts. Okay, so these are the main features of 8051 microcontroller. Okay, so this is the 40 pin IC, integrated chip. Okay, so thank you so much.